In this video, we will try to solve a problem on input-output analysis in economics. This question was asked by a brother on Telegram channel of Economaths. The question is like this. An economy produces only coal and steel. The two commodities serve as intermediate inputs in each other's production. That means we have an economy where only coal and steel are being produced, okay? And the output, the final product of coal industry is used as the input by steel industry, and the final product of steel industry is used as the input by coal industry. Okay, so there is interdependency between the two industries. Okay, also we are being told 0.4 ton of steel and 0.7 ton of coal are needed to produce a ton of steel. That means we need 0.4 tons of steel and 0.7 tons of coal to produce 1 unit of steel. Okay, similarly 0.1 ton of steel and 0.6 ton of coal, that means 0.1 ton of steel and 0.6 ton of coal, 0.6 ton of coal are used to produce 1 ton of coal. Okay, also no capital are needed, so we don't need capital. Also we are being told that 2 and 5 days are required to produce a ton of coal and steel respectively. That means to produce a ton of coal we need 2 labor days, and to produce 1 ton of steel we need 5 labor days. If the economy needs 100 tons of coal and 50 tons of steel, okay, so we have to calculate the gross output of the two commodities and the total labors required. That means how much each industry will produce and the number of labor days required to produce that very amount of output. Also we have to write down the technology matrix and we have to see whether the system is viable or not. Okay, let us first write the technology matrix. And so what is meant by input output analysis? Input output model, we also call it Leontief input output model. It shows the interdependencies and dependencies between different sectors of an economy. That means how one industry's output is used as the input by another industry and vice versa. Okay, so I will not go into the detail. I have explained the input output model in separate video. You can check the playlist input output model on this Economaths channel. Okay, so first let's try to write down the technology matrix. Okay, so how do we create the technology matrix, or I write this input output model here first. So we have steel. Okay, we have steel here and we have coal. Also we will write here steel and coal. Then we have the final demand. Let me write it here, final demand. Now let's interpret it here. We are being told that 0.1 ton of steel, that means 0.1 ton of steel and 0.6 ton of coal, 0.6 ton of coal are used to produce 1 ton of coal. That means steel industry gives 0.1 ton of steel and coal industry gives 0.6 ton of steel to produce 1 ton of steel. Okay, similarly we are being told sorry, we have 0.4 here, 0.4 ton of steel and 0.7 ton of coal are needed to produce 1 ton of steel. Similarly 0.1 ton of steel and 0.6 ton of coal are required to produce 1 ton of coal here. Okay, also we are being told that labors are 2 and 5. That means, let me write it here, labor. Okay, we are being told it takes 2 labor days to produce 1 ton of steel and 5 days to produce 1 ton of coal. Okay, and final demand is being given us here Here we have 100 ton of coal. So let me write it here. So final demand of coal is 100, and the final demand of steel is 50. Okay, so I have just wrote this very stuff in this table. Okay, so how do we interpret it? Simply says that steel industry gives a zero point 0.4 tons of steel to produce 1 ton of steel. That means zero point 0.4 units of zero point 0.4 ton of steel is used by the steel industry itself. Okay, and coal industry supplies zero point 0.7 units, 0.7 tons of steel to the steel industry to produce 1 ton of steel. Okay, similarly this tells us zero point 0.1 ton of steel is required by coal industry to produce 1 ton of coal. And similarly we are being told that zero point 0.6 ton of coal is used by or supplied by coal industry to be consumed internally. Okay, so this zero point 0.4 shows us the input output required by the steel industry to consume it internally. And similarly this zero point 0.6 ton shows us that it uses zero point 0.6 ton of coal to produce 1 ton of coal. Okay, and similarly 50 ton of steel is being demanded. So final demand comes from from the consumers, from okay, from the government. Similarly coal, the demand of coal is 100. 2 days labor days are used to produce 1 ton of steel, and 5 labor days are used to produce 1 ton of coal. Okay, now let's write the technology matrix. How do we write technology matrix? Let me give you an idea how do we first solve it. We need to find out this very equation. That means x is equal to I minus b inverse into d. Okay, this d shows us the demand, final demand. X shows the output produced by each industry, and I minus b is our Leontief matrix. Okay, now how do we calculate this Leontief matrix? First we need to find out the technology matrix. Okay, so our technology matrix, let me write it here. Technology matrix, okay, let us write it here like b is being written is like this. So we have 0 0.4 this, then 0 0.1, 0 0.7 and 0 0.6. Okay, so this will be our technology matrix. It is the coefficient matrix, or we also call it technology matrix here in this case. So it is simply formed by writing the per unit. Okay, or what we can say, it shows us dollars value of the output of each industry required by other industry here. Okay, so it is being given us by 0 0.4, 0 0.1, 0 0.7, 0 0.6. I have just written it here. Okay, so if you want to find the complete video on input output analysis, I have explained it in simple language. You can check the playlist here. Okay, so let us write this technology matrix here. I will not go into the detail here. Okay, then we need to find out I minus b. That means I denotes our identity matrix, which is of order 2 cross 2. So I can be written as 1 0 0 1. Okay, to this we subtract this technology matrix, that is 0 0.4, 0 0.1, 0 0.7, 0 0.6. Okay, when we subtract, so we will get now 1 minus 0 0.4 is 0 0.6, 0 minus 0 0.7, this is minus 0 0.7, then 0 minus 0 0.1 is minus 0 0.1, and then 1 minus 0 0.6 is 0 0.4. This is our I minus b. Okay, after that we need to find out the determinant of this I minus b. Okay, Now how do we find determinant? If we have, let us say, 2 3 4 5, this is our matrix. Okay, now how do we calculate the determinant of A? We write it like this: we just multiply the principal diagonal elements, that means 2 into 5, 2 into 5, and then we subtract the product of other two elements, that is 4 into 3. Okay, so 2 5s are 10, 4 3s are 12. Here the determinant is minus 2. Same rule I will apply here. So multiplying these two here, so 0 0.6 into 0 0.4 is 0 0.6 into 0 0.4. Okay, then we have minus from the formula. Then we have minus 0 0.7 into minus 0 0.1. Okay, so 0.6 into 0.4 is 0 0.24, minus here minus minus is plus, then we have again minus, so 0.7 into 0.1 is 0 0.07. Okay, now when you subtract 0 0.07 from 0 0.24, you will get 0 0.24 0.07. So then we will get 0 0.17. Okay, so we got I minus B is equal to 0 0.17. Okay, now we need to find out, is this system viable? Okay, we got the determinant I minus B greater than 0. Okay, now uh, for seeing whether this system is feasible or viable, we need to check the Hawking-Simon conditions. Okay, Hawking-Simon conditions ensure viability of the system. Okay, so if B is our technology matrix, this very matrix, okay, then Hawking-Simon, you know, Hawking-Simon condition tell us the main diagonal elements in this I minus B must be positive. That means these very this diagonal, if this is our matrix, this diagonal is called the principal diagonal or main diagonal. The elements on the principal diagonal should be positive. Here we can see 0 0.6, 0 0.4 or positive. Okay, this is the first condition. Okay, let me write it here. I will not write here. Okay, so I don't have space. Masa masa वो this सवाल यातमस. So the thing I want to say, to check the viability of this system, we need to see the Hawking-Simon condition. Hawking-Simon condition tells us if this is our technology matrix, okay, then we have to check the Hawking-Simon condition. Hawking-Simon condition tell us when we subtract the technology matrix from the identity matrix, we got this very matrix. Okay, now if the principal diagonals of this I minus B are positive, and if the determinant of this I minus B is positive, then the Hawking-Simon condition is satisfied. Here we can see both conditions are being satisfied, and we can say this system is viable. Okay, we have the principal diagonal elements positive in this I minus B matrix. Okay, also we have the determinant of I minus B, which is 0 0.17, which is greater than 0, which is positive. Okay, so we got two conditions satisfied. We can say the system is viable. Okay, simple thing. Now we need to find out the gross output that each industry will produce. Okay, so for that, what will we do? So let me write it again. Here I have Robert there, that we need to find out x should be equal to I minus B inverse into D. Okay, D is our, let me write it here, x denotes our, let me write it here like this, x S, that means output produced by steel industry, and xc output produced by coal industry, and D is our final demand, and we are being told their final demand is something like this: 50, 50 and 100. Okay, now let's find out the gross output. So we need to find I minus B inverse. Okay, so we got this I minus B matrix. Now to find the inverse of this, we need to first find out the adjoint. Okay, so adjoint of I minus b is equal to, so this is our I minus b, adjoint of I minus b is being given simply. If we have 2 cross 2 matrix, to find the adjoint, it is very simple. How do we find the adjoint? We just interchange the diagonal elements, principal diagonal elements. That means 0 0.6 will come down to 0 0.4, so I will write here, and 0 0.4 will come up to 0 0.6. So just interchange these two. Let me write it here. If we have 2 3 4 5, okay, let this be our matrix. If I want to find the adjoint of this matrix, how do I find? I just transpose the principal diagonal elements. Okay, so 5 comes here, 2 comes here. Okay, after that we need to interchange the sign of the other elements. Okay, non-principal elements. If this is positive, it becomes negative. If this is positive, it becomes negative. So here we have minus 3, minus 4. Okay, just interchange the principal diagonal elements and only change the sign of the non-principal diagonal elements. Okay, with our interchange. So here we have 0 0.4, this will come up, and 0 0.6 will come down, and we need to change the sign of the non-principal diagonal element. This is minus 0 0.1, it will become plus 0 0.1, minus 0 0.7, plus 0 0.7. Okay, this is the adjoint. Very simple. Okay, this rule only applies when we have 2 cross 2 elements. Otherwise we have to find out the factors, cofactors, and do variya mehnat mashkat. Okay, so I will not go into that very. I have explained that very stuff in the matrix algebra in economics also. Okay, so don't worry, you can find all the stuff in this on this channel rather. Okay, so first we need to find the adjoint of the matrix. After that we need to find the I minus b. So I minus b inverse is being given by 1 divided by the determinant of I minus b into adjoint of I minus b. Very simple thing. What does this mean? So I minus b, this 1 upon I minus b, which we calculated 0 0.17. We have 1 upon 0 0.17. To this we have adjoint, which we calculated here. What is adjoint? This 0 0.4, 0 0.7, 0 0.1, and 0 0.6. Okay, now what is x? Now x is equal to, let me write it here, xs and xc will be equal to I minus b inverse. I minus b inverse is equal to 1 upon 0 0.17. Then we have 0 0.4, 0 0.1, 0 0.7, 0 0.6. Okay, and to this we multiply d. What is our final demand? That is 50 and 100. 50 and 100. Okay, very simple thing. Now what we need to do here, we need to multiply these two very matrices. Okay, so how do we multiply these two matrices? Let us find out. Okay, we use the formula RC. Actually it is not the formula. So we multiply each row with column. That means each element of the row with its corresponding element in the column. Okay, so we have 1 upon 0 0.17. Okay, now multiplying each row with its column. So this 0 0.4, we have 0 0.4 into 50 plus 0 0.1 into 100. Okay, multiplying this row with this column, then this row again with this column, that is 0 0.7 into 50 plus 0 0.6 into 100, 0 0.6 into 100. Okay, so I will when you solve, this will come out to be like this, 1 upon 0 0.17, zero 0.4 into 5, you go pinch dage punch through. So we have 50 here. No, it cannot be 50 here. So 0.1 into 100 is 10. Now punch dage gaye. So 40% of 50 comes out to be 20. So 20 plus 10 is 30. So we will have 30 here. So 70% of 50 will be 35, and 60% of 10 is 60. 60 plus 35 is 95. Okay. So multiplying, dividing it like this. So let me write it here, which will come out to be 30. So this 0 0.1 will be divided to each of these terms. So 0 0.17 divided by, actually it is not divided, so we have also 95. Let me write it here in clear terms. Okay, so we have 30 divided by 0 0.17. Should I rub something here? Parishan gai jai na sin. Karo se to karo kya, that means our x will be equal to, now 30 divided by 0 0.7, we have 30 divided by 0 0.17, and we have 95. 95 divided by 0 0.17. Okay, so this will come out to be, actually I have calculated it, it come out to be 176.5, and this is 558 point something, it was 5, or I'm not sure what exactly was it. Okay, so we got this very thing here. Now what we need to do, actually I don't have space, so this 176.5 denotes the steel output. Okay, so let me write here. So our steel output will be equal to 176.5, and coal output is equal to 558.8. actually it is here 8. Okay, now we need to find out the total number of laborers required. Okay, so total number of laborers required, let me write it here. So total laborers will be equal to, okay, we know that to produce 1 ton of steel we need 2 labor days. Okay, so here we are producing, actually it should be 5 here. Okay, so let me write it here. This is 5, this is 2. Okay, we need 5 labor days to produce 1 ton of steel. Okay, so total labors will be equal to our total output, that is 5, that means number of labor days into uh, number of tons of steel output produced, that is 176.5 plus number of days required to produce 1 ton of steel into number of tons sorry, number of tons of coal produced, that is 558.8. okay, so you can also write it like this: 5 into our steel output plus 2 into coal output. Okay, so this is, and this will come out to be 2000 approximately labor days. Okay, so total labors required will be equal to 2000 labor days. Okay, I hope I make myself clear in this video. Okay, so let me again write it here. So steel output was, total labors will be equal to total total laborers will be equal to, okay. So what we are being told here, to produce 1 ton of steel we need 5 labor days, okay. Since we are producing 176.5, then that means number of labor days to produce 1 ton of steel into number of tons of steel being produced, okay, that is 176.5. Similarly, we have number of labor days required to produce 1 ton of coal, that is 2, into number of units of coal being produced, that is 558, okay. Let me give you an example. If we have to produce uh, if we produce, let me write it here like this, if 1 centimeter, let me write it here, it, no, it will not be a viable example here, so how can I explain it here? uh, Let me write it like this. If one labor, if one labor costs us 5 rupees, then 30 laborers will cost us 30 into 5, okay. Just multiply this. Similarly, if if 1 ton of a steel requires 5 labor days, okay, then 176.5 tons of steel will require 176.5 into 5. This is simple mathematics, okay. So I hope I make myself clear in this video. There was another question, I was not able to write that very question here, so let us hope I can solve that very one in another video. I hope I make myself clear in this video. Thank you.